Hello, this is Mr. Angus Wangus back for another vid. My previous video I examined the PMH and its role as an electromagnet and also as a generator. But I mainly made that video to show that the effect I was getting with the U-core PMH was not a delayed lens type effect, a la Heinz. Most people are familiar with him. You might want to look him up. I know he removed his videos. Someone told me why, but I don't know enough about that. So, but they're still out there. Some other people have uploaded them. So from the start of my experiments with the PMH months ago, right? I could see that it wasn't a delayed lens type effect or due to capacitive reactance, and we're going to talk about that, what it is and all that, or theoretically what it is, delayed lens. But I could see that the reaction I was getting with the U-core was not that delayed lens effect, right? So I was a bit excited about that, and led me through a bunch of tests and brought me here. These last two vids I'm making are a bit overdue, I think, but not really, in the sense that, I've been reluctant. People ask, oh, give me the recipe, wire gauge, this, that, but I've been reluctant to do it. Although I could see that it's different than the theoretical delayed lens type reaction. I was a little suspect, still testing, but these two videos are culminating nothing really new that I've said, I don't think, in all of the videos that I've made in the last months, but kind of bringing it all together. So the last vid I made was an attempt to show that. It wasn't due to this delayed lens. So I've been considering for like a week now. Different reasons it's taken me a while to make this video, but I've been wanting to do it for a week about the delayed lens effect, right? This Heinz effect. And now he's explaining, now what is it, right? What's delayed lens? Now, Heinz gave great explanations as to the theory about, about it having to do or depend on the impedance of the coil, which is AC resistance in the coil basically, and it's also dependent on frequency. It's important, right? It's dependent on that. But allow me to focus in here a little bit. Okay, so basically when they're talking about this delayed lens or capacitive reactance, right, what they're talking about is the windings on the coil. Where's my pointer? Okay, let's say this is a coil, right, labeled here. It has an iron core, right? And it's wound in whatever direction. Winding direction doesn't matter, guys, except to establish poles of the coil. Just like flipping it, just like changing the current in it. Just want to mention that again quickly. But if we zoom in on a small portion of that coil, so we've expanded out to this square here from that coil, we can see a cross section of the wires that are coiled around that coil, right? And what happens is, as the magnet passes by the core and stimulates the copper, it produces a potential difference in voltage, right? Well, what also happens is that this coil develops its own capacitance depending on its makeup, its size, its shape, the size of wire, gauge, length, how many turns. Theoretically, This is the delayed lens theory, right? And so the wires next to each other, not only do we have a built-up voltage potential between each end of the wire wound on the coil, but in between each wire on the coil in itself, there's a slight difference in potential from this wire to this wire, from this wire to this wire to this wire, right? From here to here, there's another winding for it to get there, which results in a small difference in potential, right? This section of the wire is going to have a slightly different potential than this section of wire because there's slightly more wire. And it acts as a capacitor. The coil will build up its own capacitance. Now if you think of the copper and the wire as the plates of the capacitor and the shellac on the wire in between the wires as the dielectric, this is just what a capacitor is, right? We have the two metal plates, that's a D by the way, for dielectric, and we have a dielectric in the middle, right? And so the coil does the same thing in its own way, and it builds up capacitance with the number of turns, right? If you increase the number of turns, you're going to increase the capacitance of this coil, right? So therefore, if you're we'll get to that in a second. So not only that, but if you, let's say, decrease the size of this wire, the potential difference is going to be slightly higher between this wire and this wire because it's thinner. And that will also increase the capacitance, right? So that brings us basically to saying that, oh no, yikes, sorry guys, a little bit of vertigo, sorry for the vertigo. Okay, so if we increase the frequency of the magnet passing by this coil, increase the frequency, right? It's going to increase the voltage potential between those wires, and it's going to increase the capacitance of the coil. Also, if we increase the impedance, or analogously saying the resistance, sort of. So if we increase the impedance of the coil, then also we increase the capacitance, right? Because of more impedance, there's going to be, again, a higher potential difference between the wires, and it's going to increase the capacitance. Basically, in a nutshell, that's what delayed lens is. Or when we have acceleration under load, we short the coil and our wheel speeds up. This is one theorized way to do it, and I'm wording it as theorized because we're about to do some demos that calls this into question. Now this, I'm going to get to this after, guys. Okay. So basically what we're going to do is I have my wheel set up here, and we're going to measure RPMs, right? I've weighed, I'm going to be using two different coils and eventually two different cores. This is 22 gauge wire I'm going to start with, and then I'm going to go to this coil, which is 14 gauge. It's very much very close to this mains wire, whatever that is. I think it's about 14 gauge. I hope that came out. So then I'm going to demonstrate two sizes of wire in the same position, on the same core, in the same position. And we're going to look at the RPM. Now if you move these coils up and down the bar, it's going to change the current flowing in the wire, which is going to change things. But in this video I don't want to get into that. I'm going to keep these coils, and now they're basically the same shape. They're each a kilogram of copper. This one's 14-ish gauge. This is definitely 22 gauge, much thinner. So basically we know the weight of the coils, we know the gauge. They're both the same weight, 1 kilogram. They're very roughly the same size. This is on a spool that I made. This is kind of slightly different shape, but they're the same length and the same size hole in the middle. They're wound on. So first I want to demo the 22 gauge. This is 1 kilogram. Again, I'm going to keep it right in the middle of this. This is a piece of rebar. I'm going to keep it right in the middle of it, and we're going to have a look at what shorting it does to the RPMs. And then we're going to switch to this much thicker gauge wire in the exact same position on the core. We're going to short it out, and we're going to look at what it does to the RPMs of the wheel. Now, understanding the basic concept of the so-called delayed Lenz effect, there should be a difference between these coils with the test that I'm doing here. There should be a difference because the smaller gauge wire should have a higher impedance. It should have a greater capacitance at the low RPMs or frequency that we're going to be moving at. And we'll see if there's a difference. You might be surprised. So theoretically, according to this theory, there should be a difference. Most definitely should be. So we'll see if there is. I'll be right back. Okay, so we're back. All set up. And I've got the motor running. It's up to speed. Now again, this is a piece of rebar. I have the coil in the middle, which I will be putting this coil in the middle, same spot in this piece of rebar, and we're going to see the difference. Now, one thing I should say is that the input to the little motor driving this wheel is at 50% duty cycle, which there's a little notch there at 50% in the potentiometer, which that's where it's going to stay. I'm not going to change the input at all, just so you know. These distances are going to be the same. It's not going to be touched at all. I'm just going to slide that off and slide the other one on. But we'll see. Let's check the RPM to start with. Now we're at 400, if I can hold it still, 414 RPM. 414. So now what I'm going to do is I'm going to take my trusty clips and short this together, and we're going to watch the RPM. I can hold it straight. We'll give it 1 second. It's not going to speed up a whole lot. So we started at 414, I believe it was, and now it was up to 432 so far. So it's definitely accelerating. The wheel is accelerating under load, right? It's shorted, and the wheel has accelerated a bit. And That's where we're going to be. 439. I hope you saw that. It's hard for me to see in the, we'll call it 440. 440. Okay? So, we'll disconnect. And what I'm going to do is slide this other coil on. I might even do it without even stopping from. Okay, so I'm going to slide this one off. Listen carefully. Slide this one on. There we go. She's in the middle. Alright. We're going to have to let the wheel settle back down. It has. I don't know if you can see that. So we're at 413. I guess that's where it was previously. Depending on how steady my hand was or which moment we looked at it. So 413, 414. Now what we're going to do is, oh, let me get these terminal ends into view. Okay, you can see those here. So what we're going to do is short this coil together. And we'll have a look at the RPM. And you can see that it's speeding just like the other coil. And once again, we'll give it a second. Just so you can see that she's shorted what I did there. Someone commented that I have the noisiest tripod in the world. Thank you very much. I don't mind, it was free. My friendly neighbor gave it to me. Okay, so once again, if I can keep my hand steady. We're at roughly, it accelerated to the same spot, right? 440, 441, maybe even 442 is what I should call it. There you go, 442. Now I'm going to disconnect, and I'm going to turn this off, and I'm going to straighten up things and then be right back. Okay, back. So now what I have, I've taken this, you can't see it, rebar core off, and what I have now is a laminated core, very similar to other experiments I've done in the past. It's like a rebar tie wire. And this core and this rebar core are exactly the same weight. So I made this exactly the same weight as that. They're both 200 grams exactly. Actually, one of them is 200 and one of them is 199 grams. So they're within 1 gram weight of each other. So same weight in iron, and that is minus the tape holding together, just so you know. So I try my best to make it as fair. You know, you're doing an experiment, you want your parameters to be good and valid, right? So we want to be able to determine something from this. Now again, I have it in the middle of the core, and first thing you're going to notice is that this goes a little faster with the laminated core. without it engaged, 425 RPM. It's at speed, it's rested. So what I'm going to do now is short it. I'm showing this difference in cores because it's very interesting. There's other things that I could be including in this, like the output, right? The difference in output, or if I move it up and down the core, the difference in output with respect to a difference in reaction. But I want to keep it as simple as possible with the same parameters so that we can make deductions from it, right? Just comparing different size wires. We've already done that with the solid core. Now we're doing it with the laminated core. So it's slowed down. We've got more of a normal reaction, right? Kind of. Lenz reaction. So the wheel has slowed down with it being shorted. About 10 RPM, thereabouts. From 425 to around 415, 416. So now what I'm going to do is disconnect. Pull that off carefully. Throw it in the corner. Slide this one on. Center. Right. So theoretically, according to the delay Lenz theory, this should make it slow even more, right? Just like we thought the last one would. In this instance, this thick 14 gauge wire as compared, that was 22 gauge wire we just saw. This should slow the wheel more. And we'll see if it will. Let's see what we're at. Alright, we're back at 426. So 427. Okay, so we'll short it. Right. She's shorted. And it should be slowing, right? And it is. We'll let it sit for a minute. Make sure this is straight. I think it was favoring this end. So we're right in the middle. We'll let it settle to where she needs to be at. And we'll have a look at the position on the core, right in the middle. And we'll have another look at the RPM. 418. 419, right? I think I would call that 418. 418. So with the larger wire, thicker, shorter, fewer turns, it slowed down the same amount as the 22 gauge. It was the 22 gauge wire is many more turns. Okay, I'm going to cut this and I'm going to come back. Okay, a brief summary and then a word about Thane-Hein's actual setup. Maybe a speculation and a hint at my direction. Believe it or not, a lot of you, this may seem like, oh, it's an answer and can't go any further. I already see a way to go further. So, and I know, oh, you can't put more, you can't just keep putting more wire on the core, you know. I know that, right? I'm thinking of something else. But anyways, that's an old idea and yada, yada, yada. Sorry to yammer. So anyways, what we saw here was, we talked about what the delayed lens effect was. It having to do with the capacitance buildup, capacitive reactance of the coil, right? And what this does is delay the electric field created by the coil. When a magnet passes the core and there's a coil on the coil normally makes its own magnetic field, right, which opposes the magnetic field of the magnet on the wheel, and it causes the wheel to slow down due to what we call Lenz, the Lenz effect. So now we've seen, and this is nothing new, right? Thane Hines has done this among scads of other guys on YouTube, right? Investigated this to some degree or another. As have myself. So what we saw here was 1 kilogram of 22 gauge, many more turns than what's on this coil. Same basic shape, length, the core hole, or the inside diameter of the coil is the same in both cases, same length, same weight. We have a kilogram of copper here, but this winding has much less length. If we stretched them out, this coil would stretch out way farther than this one. They're the same weight though. So with the delayed lens theory, what we should have anticipated seeing, and now again, sorry, this would all change at a higher frequency. If the higher RPMs would increase the frequency, and the reaction would be better in both cases, right? But I think it would be the same. Both better, but both the same. But in this test, I wanted to keep the frequency the same throughout the testing, right? So we kept that as a constant so that we could look at a change in the capacitance of the coil, right? And I think we did that. And basically we saw no difference, right? We should have seen a difference, I think, with the conventional understanding or explanation of delayed lens, right? This capacitive reactance causing a delay in that back magnetic field, right? That because it's delayed, we don't see the lens effect. That's what the delayed lens effect is all about, theory. But this sort of calls it into question, right? Now, I think we can see the correlation between the solid iron and the effect, the positive effect or acceleration under load, right? And using the laminated core, we got a deceleration under load, or a standard lens effect, right? So we see the correlation between the solid iron and the effect, right? Probably why very soft irons becoming harder and harder to find, maybe, I don't know. Just a speculation there, but so hopefully this showed. I woke up today wanting to do a delayed lens effect video and explain this, right, to everyone, and the difference between this and the effect I'm seeing with the U-core or PMH that Ed Leeds Scallon made and his sons. Um, but what ended up happening was, and this is very, very, very cool in my mind, today was a very productive day for me. This might not seem like anything to many people, but this is a big deal. This is a really big deal. We saw basically no difference, right? No difference when we used the solid core, and we saw basically no difference when we used the laminated core. We saw a difference between the laminated core and the solid core, which I think eludes or hints at the actual underlying effect that's happening. But there should have been a difference between these coils because they're very, very different in wire gauge size, and thus at a same frequency there should have been a different capacitance. Because this coil, I already know, is less than 1 ohm. This one is over, what is it? I want to say 18 ohms. This is way less than, this is less than 1 ohm. Somewhere near 18. Dang, I should have measured them. I wasn't thinking. But I bet if I did measure them, that's what they would be. So this brings up questions about this delayed lens theory, right? Perhaps Thane was getting a reaction for another reason. Which brings me to my final point. Now, I think he called his machine a Regen X or something like that. Propatia, something like that. Peripatia, maybe. Anyways, that's what he liked to name it. So his setup, I had a better look at his setup. And basically what he's doing is the same as Ed's core. He had 3 prongs on his setup, and the magnets on his wheel were alternating, and they alternate like this. South on this end, leg, north, south, right? So it's basically like a perpetual motion holder. Same thing, same idea. The norths and the souths are communicating, right? And although Thane used, here's his T1 winding, right, which I think was a very smaller gauge wire, and then his T2 windings on these legs were a much heavier gauge wire. And I think it wouldn't matter. I think that those coils that he was using when he shorted all of them or both of them, they were inducting one onto the other, and his end voltage and current, which I don't believe he ever showed, or maybe he did, and he showed his input a lot, but I think they were inducting on one another and ending up with one current and voltage, just like using an aluminum spool would do. So I'm thinking now, after doing the demos too, and I just wrote down, it's the same as the PMH. We have communication between the poles, right? And then as the magnets move, this becomes north, south, north, and it's just an alternation of the same thing. So basically, there you go, another long-winded video from Mr. Angus Wangus. Again, I woke up wanting to explain the delayed lens and the difference between that and what I'm seeing with the U-core. And what ended up happening was I ended up questioning the whole delayed lens effect in itself. I think it's due to magnetism rather than capacitance of the coil. Now, a next good vid for me to make would be to show the difference with a different induction. If I move that coil this way, I'm going to get more current flowing in the wire. If I move it this way, I'm going to have less current flowing in the wire. That would be a good thing to show. That's a factor. I didn't want to include it in all these tests because I wanted to keep it as simple as possible to show that there is hardly any difference. You know, this is not NASA labs, right? Or JPL or anything like that. But this is the best I can do. I got these cores within 1 gram, so we saw the difference there. These coils are exactly 1 kilogram each. And there you go. I have some things I want to try now, 100%. I'm very, very, very glad I did this. It crossed my mind a week ago, something I've been wanting to do, but honestly, it wasn't a high priority for me in moving along with this idea. But I woke up today wanting to do it, and I'm so very glad I did, because this steers me back in the right direction. And don't know what my next vid will be. The direction I'm going, I'm not going to say, because I'll show it in the vid. But anyways, there you go. Still working on it. I have to make a new core, a new setup, and we'll go from there. I hope you enjoyed. I hope this was informative for you guys. I appreciate all the support and positive feedback, guys. I get a lot of negative feedback. I was called a scammer the other day and a liar, you know, like you're not allowed to use certain words like perpetual motion and whatnot. But if people keep in mind these laws of thermodynamics, there's only one way to use those words. So, you know, please save yourself some embarrassment before you make a nasty comment on my videos. Yada, yada, yada. Okay, there you go. Hope this is informative. Thanks for watching. Take her easy, and my next vid should be interesting. Talk to you later.